Our topic for today is domain and range.
Let's recall. What is a domain and range? Domain is a set of first coordinates. There are the values of x. While range is a set of second coordinates. There are the values. Here are some restrictions that we must consider in finding the domain and range of a function. For fractions, denominators should not be equal to zero because any number divided by zero is undefined. Number two, radicand should be non-negative. Radicand should be greater than or equal to zero. Let's try some examples. How are we going to get the domain and range if given the equation? You should remember, if the value of x and y is polynomial, the answer would be set of all real numbers, except for range if there is a restriction. Number 1, 3x minus y equals 7. To find the domain, solve for y. So of course, the equation will be like this. Negative y equals negative 3x plus 7. We have to transfer 3x to the other side. And since it is negative y, we have to divide it to negative 1 in both sides. So we have y equals 3x minus 7. Since y is a polynomial, we can conclude that our domain is x is a set of all real numbers. Find the range, solve for x. We have 3x equals y plus 7. Since there is a constant in x, we have to divide both sides by 3. So we have x equals 1 over 3y plus 7 over 3. Since it is polynomial, we can conclude that our range is y is a set of all real numbers. Number 2. Y equals x squared minus 4. To find the domain, solve for y. Since y equals x squared minus 4 is already expressed for y in terms of x, and it is polynomial, we can conclude that our domain is x is a set of all real numbers. To find the range, x squared minus y plus 4 by using square root method to get x. Our x will be positive or negative square root of y plus 4. Remember, I have given you some restrictions about radicand. Inside of the radicand should be 0 or greater than 0. Let's equate y plus 4 greater than or equal 0. Therefore, y is greater than or equals negative 4. So our range will be y such that y is greater than or equals negative 4. Our last number, 3y plus xy equals 2x plus 1. To find the domain, we have to solve for y. Because we have two y's, we have to factor or group them. So we have y quantity 3 plus x equals 2x plus 1. To get the y, we must divide both sides with 3 plus x. So we get y equals 2x plus 1 over 3 plus x. Our value of y is rational or a fraction. We have a restriction about fractions, right? It is the denominator should not be equal to 0. For example, if our x in the denominator is negative 3, then we get an undefined value. So we must equate 3 plus x should not be 0. We have x is not equal to negative 3. Then we can conclude that our domain is x is a set of all real numbers except negative 3. To find the range, solve for x. 3y minus xy equals 2x plus 1. We have to group them, those who have the variable of x. So xy minus 2x equals 1 minus 3y. However, we can still see 2x. So we must factor them or group them. So we have x quantity y minus 2 equals 1 minus 3y. To get x, we must divide y minus 2 to both sides. Now we get x equals 1 minus 3y over y minus 2. Still, we have a restriction because x is a fraction. Denominator should not be equal to 0. Then our result will be y is not equal to 2. Therefore, our range is a set of all real numbers except positive 2